Hi everybody, this video is going to show you how to do long division of polynomials. Now remember, what we've already done in class so far is we've learned how to factor and solve quadratics, which is degree 2. That would be something like x squared, biggest exponent is 2, and cubics, that would be something like x cubed, ... Degree 3, biggest exponent is 3. The whole goal of factoring and solving is to find the x-intercepts or the solutions. And just keep in mind that when we talk about x-intercepts and solutions, we mean these things right here. Now the thing with polynomials is polynomials can have any degree. It doesn't have to be degree 3 or degree 2. It could be degree 4, 5, 6. It could keep going forever. Ways that you've learned how to factor so far in this class or in previous classes are the basic factoring, like what multiplies to this and adds to this, guess and check, greatest common factor, difference of two squares, perfect square trinomials, grouping when there are 4 terms. Remember, grouping only works for 4 terms, and sum and difference of 2 cubes. Now the thing is, we want to be able to factor, solve, and graph all polynomials. And there are some polynomials that cannot be factored using any of these methods. Like you have a lot of methods so far, you've learned almost every factoring method, but there are some where none of those methods will work. They just cannot be factored. And one example, or actually 2 examples, would be these here. I have a 4th degree and a 3rd degree polynomial. As soon as I see 4 terms, I'm thinking grouping here for both of them. If I were to try grouping here and factoring out the biggest thing they both shared, I would get x minus 8. These two share nothing, so it's just 11x plus 6. And since these 2 parentheses expressions aren't the same, it isn't going to work. You can't do it. So as of right now, we have no idea what to do, and we wouldn't be able to solve it. If I try this one here, I could take x squared out, leaving me with 2x minus 3. I could take a negative out here, leaving me with 5x plus 12. Again, definitely not going to work. These aren't the same. The thing that polynomial division allows us to do is factor and solve more polynomials than we were able to do with our factoring methods. So the thing is, like, if we can't factor it, like if we run into this problem right here, how are we supposed to solve and find the x-intercepts? Normally, before division, we would just stop here and say, well, we can't factor it, we can't solve it. But now with polynomial division, it's going to open up many doors for us whenever we deal with polynomials here. There's going to be 2 types of polynomial division. You're going to learn both of them in this class. First, we'll spend, 1 or 2 days on long division, and then you'll learn the shortcut, which is synthetic division. Long division is based off of that same long division you learned back in elementary school. It works for all polynomial division. That's very important to remember. The thing with synthetic division is it is actually a shortcut for long division, but it only works if your divisor, or the thing that you're dividing it with, is linear, like the degree is 1. So if you had something like 2x cubed plus 5x squared plus 6 divided by x squared minus 4, this is not linear, so you could only do long division here. You would not be able to do synthetic division. So that's something to keep in mind. All right, so before we do polynomial long division, let's make sure you remember basic long division, like the kind you did way back in elementary school. So let's take a trip down memory lane here and do 52,784 divided by 4. And actually, I'm going to do this one below. And also, I want you to do, so write these down in your notes. If you did not get all of these notes copied down, make sure you go back and get all the stuff copied down so far, because you're going to need it. The other one I'm going to have you do is this. 32 going into 3,587. All right, pause the video and go ahead and do these 2 out all the way. Make sure you're actually pausing the video and doing this. All right, so here's the result of the first one, what you should have gotten. You should have gotten a remainder of 0 here. And the fact that you have a remainder of 0 means that it divided evenly. And the 4 vocab words you need to remember for any kind of division is the dividend is what you're dividing into, the divisor is what you're dividing by, and the quotient is your actual answer. So my answer is 13,196. One thing that we're going to be practicing is something called the summary statement. I'm going to have you write a summary statement for every single division you do. And the reason is it states your answer in a clearer way, and it will lead right into factoring. Okay, so this one here, I could say that 52,784 divided by 4 equals 13,196. That's probably how you would have written this in elementary school. You could put a plus 0 at the end, but since plus 0 is nothing, you really don't need that. Another way of saying this is that 52,000 times 784 is equal to 4 times 13,196. These two statements are equivalent, meaning they are the same exact thing. All I did to go from here to here was multiply each side by 4, moving that over to this side. Let's take a look at the other one, and the other one you did not get a remainder 0. So if I wrote a summary statement here, I could either write, where's my thing, 3,587 divided by 32 equals 112 plus 3 over 32. Or you could write 3,587 equals, so 3,587 is 32 times 112 plus 3. Again, these two statements are equivalent, but we are going to want to get used to writing it like this, because that's going to lead into factoring when we do it with polynomials. So speaking of polynomials, let's do our first actual long division with polynomials. Now I want you to notice the similarity between the problem you just did and this right here. I basically took our exact same problem and turned it into a polynomial. So I started with constants here and here at the end, and moving to the left, I went up in degree 1, 2, 3, and 1. So I color-coded it so you can clearly see what's going on. So let's go ahead and do this with long division here. So this is how long division works. You are going to take the first term here and the first term here. And you're going to say, all right, what would I multiply 3x by to get 3x cubed? And the answer to that is x squared. You would multiply 3x by x squared, you'd get x cubed. And then you would go ahead and multiply x squared by 3x and 2. So x squared times 3x is 3x cubed. X squared times 2 is 2x squared. And just like with normal long division, we're going to subtract. That's what we did right here. We subtracted. Now, I would highly recommend doing parentheses because, well, 3x cubed times 3x cubed is 0. You should always get 0 the first time. If you don't get 0, you did something wrong. What people do here is they're like, oh, 5x squared plus 2x squared is 7x squared. But that's not correct because you have to distribute the negative. So it's really 5x squared minus 2x squared, which is 3x squared. Just like before, I'm going to drop down the 8 now, except it's 8x now. So then I'm going to think, all right, what do I multiply this by to get this? You're always going to start with the 3x and think, what do I multiply it by? So you'd multiply 3x by x to get 3x squared. So you're going to distribute the x, just like before. 3x times x is 3x squared. X times 2 is 2x. Just like before, we subtract the whole thing. I'm going to get 0 here, as always. 8x minus 2x is 6x. Last step, bring down the 7. What do I multiply 3x by to get 6x? A 2. You're going to multiply by 2. 2 times 3x is 6x. 2 times 2 is 4. Subtract the entire thing. I get 0. 7 minus 4 is 3. Same remainder. Notice when you do long division, there should be this diagonal trend here as these terms cancel out. And let's write the summary statement here. So my summary statement, the one I want you to get used to, is let's write this with polynomials. So here's the summary statement that you're going to get used to. You take what you began with, and it equals your divisor times your quotient plus your remainder. Just like here, but with variables. So go ahead and jot that down. Now that was fun, so let's do it again with a different one. So here we're going to do a 4th degree divided by a 2nd degree. So let's go through this one a little bit quicker here. So all right, I'm always going to take this outer one and this outer one furthest left and think, what do I multiply this by to get this? So I multiply x squared by 6x squared to get 6x to the 4th. Multiply this by the entire divisor, so giving me 6x to the 4th plus 6x cubed minus 6x squared. And subtract the whole thing. I'm going to get 0 there. Negative 1x cubed minus 6x cubed is negative 7x cubed. Negatives are really the only spot I see people mess up a lot here. Negative 1x squared minus negative 6x squared, that's plus 6x squared now, is 5x squared. Bring down the next term. And think, okay, what do I multiply x squared by to get negative 7x cubed? First of all, negative 7x. Okay, bring this all the way over. So negative 7x times x squared. I get negative 7x cubed. Negative 7x times x is negative 7x squared. Negative 7x times negative 1 is positive 7x. And then we're going to subtract. Be very careful with the negative right there. Negative 7 minus negative 7 is 0. 5 minus negative 7 is 5 plus 7, 12x squared. 9 minus 7 is 2. Okay, last thing, bring down the negative 3. What do I multiply x squared by to get 12x squared? That would be 12. Multiply 12 by all of those things there, giving me 12x squared plus 12x minus 12. And subtract. So I get 0 there. 2 minus 12 is negative 10. Negative 3 minus negative 12 is negative 3 plus 12, which is 9. Here's my remainder. So my summary statement will be, oops, you get your original is equal to your divisor times your quotient plus your remainder. You really don't need a plus and negative there. You could just put minus. It's up to you. Okay, so I'm going to give you one to try now on your own, and then you can come back and check to see your work. It's very important you're actually trying this on your own, not just speeding ahead to see the answer, because practice is really where you're going to get comfortable with this. So pause the video now and try this and write your summary statement at the end, and then check your work. The interesting thing about this problem was right here. I did this problem 2 times, and hopefully whether you completely eliminated it and went right to this x squared here, or whether you kept it as 0x cubed and then went to the x squared. Hopefully no matter what happened, you ended up with the same answer. This here is not a negative, it's just an x. Notice that if you had completely crossed out both of these, which is 0, you had to drop both of these at the same time because there was this negative 3 that you had to combine with the negative 2 to get 1. Here's a summary statement. If you used what we're going to call placeholders, actually make a note here, placeholders, they have a coefficient of 0. Anytime you use placeholders, it's going to keep everything lined up perfectly for you, and you don't have to worry about bringing more than one thing down at a time. All your x cubes will be together, all your x squareds, all your x's, all your constants, all your fourths, etc. We're going to do a problem in just a second where we drop the placeholders, and it's going to possibly not make it as perfectly organized here, and you have to be more careful with your combining like terms.